Circles W1 and W2 with radii 961 and 625 respectively intersect at points A and B. A third circle W is externally tangent to both W1 and W2. Suppose line AB intersects W at 2 points P and Q, such that minor arc PQ is 120 degrees. Find the distance between the centers of W1 and W2. We have circles W1 and W2 with radii 961 and 625 respectively, which I'll call R1 and R2. The circles intersect at points A and B. We now have circle W, which intersects line AB at points P and Q, and this minor arc PQ is equal to 120 degrees. We want to find the distance D between the centers of W1 and W2, which are O1 and O2 respectively. Suppose the center of W is denoted as O, and its radius is denoted as an unknown variable R. If we think about what the 120 degree arc condition means, it simply means that the distance from O to line PQ is equal to R over 2. Because if angle POQ is equal to 120 degrees, then each of these angles must be equal to 60. And the cosine of 60 is 1/2. So now we're going to define the function f from the plane r squared to the set of real numbers r. And f satisfies f of x, where x is a point, is equal to the power of point x with respect to circle W1 minus the power with respect to W2. By linearity, this function is linear, as I proved in my previous video. In order to work with this function, we need 3 points or more on the same line. However, we do not have 3 points on a line right now in this diagram, but we can force them onto the same line by dropping O and its projection M onto line PQ, the radical axis of W1 and W2, both of them projected onto line O1, O2, which is perpendicular to the radical axis. I will call the projection of M, N, and the projection of O. Note that nothing changes under this projection. We'll still have equal f values. Note that f of m is equal to f of n, because both m and n lie on the radical axis of W1 and W2. So f of m equals f of n equals 0. Also, line OR is parallel to the radical axis of W1 and W2, so f of O equals f of r. We don't know what it is yet, but we do know that f of O equals f of r, because OR is parallel to the radical axis of W1 and W2, and f is constant. So now we have forced all points, including O and M, onto line O1, O2, which is perpendicular to the radical axis of W1 and W2. So we have f of O1 is equal to the power of O1 with respect to W1. It's inside W1, it's the center, so its power is going to be negative. Its power is going to be minus R1 squared with respect to W1, minus its power with respect to W2, which is D squared minus R2 squared. So minus D squared plus R2 squared. And f of O2 is equal to the power of O2 with respect to W1. That's just D squared minus R1 squared, minus its power with respect to W2, which is minus R squared, minus R2 squared. So minus R2 squared is going to be plus R2 squared. F of n is just 0 because it lies on the radical axis of W1 and W2. F of r is f of O. And f of O is just r times r plus 2r1 minus r times r plus 2r2. So that's r times r plus 2r1 minus r times r plus 2r2. And that's just r times 2r1 minus r times 2r2, or just 2r r1. Now we can use linearity. We know that by linearity, f of n minus f of r over f of O1 minus f of O2 equals nr over O1, O2. And nr over O1, O2, well, nr is just mo, and mo is r over 2, while O1, O2 is the distance we want to find, d. So r over 2 divided by d, that's f of n minus f of r, so that's just 2r times r2 minus r1. 0 minus 2r r1 minus r2 is 2r times r2 minus r1. Then f of O1 minus f of O2, some things cancel out. The minus r1 squared cancels out, and the r2 squareds cancel out. So that's just minus 2d squared. Minus d squared minus d squared. That's minus 2d squared. So we can cancel the minus 2, and we get r over 2 divided by D equals R times R1 minus R2 over D squared. And now we can cancel both R and D. We get that 1/2 equals R1 minus R2 over D. So D equals 2 times R1 minus R2. Looking back at the problem statement, they tell us R1 equals 961 and R2 equals 625. So using D equals 2 times R1 minus R2, we get that D equals 2 times 961 minus 625, which is 2 times 336, or 672. Thank you for watching, and please follow my channel if you would like to see more videos.